Okay, so this is basically part two of some of the tools I made during my apprenticeship and things I used to make my life easier and help me remember the things I needed to remember. And let's get into this and I'll show you what I got, and we'll maybe at the end of this thing discuss a little bit about what it's like to serve an apprenticeship in the mid-70s. So let's take it from here and see what we got. Okay, this part I know you've seen before. Here's the pattern for this. And actually this is a brooch that I turned. Basically an Allen wrench that has been cut up and chopped out. I drill a hole through here and drive this pin through there. So there's the thing, and this would be driven in. Once I lined it up, I would drive it through like so, and it worked really good. So, and this is, yeah, you can see the shape of this. Just an Allen wrench has been modified and fits in the way I need it to fit, and it all works. And that was necessary at the time. This one is for, we did a lot of large work and we used 1-inch plywood headers and put staves over the top of it. Most of that was shipyard work and big cylinder stuff. So what this is you'd butt it up against a board like this. You'd have a center line drawn on the board and you'd use this little pinhole in there to use your trams or dividers to mark your circle. We did a lot of big cylinders. This is my own invention, me being a smart ass I guess, but basically this is a solid block of Bondo. I've got several of them. What I did, I started out with a piece of 1/4-inch plywood and mix up Bondo on it, and instead of sanding it all off, I just wipe it smooth and clean it off, and after several layers the plywood's gone, and now I got a big nice chunk of Bondo, and I call that my Bondo board. So that all works. So, and everybody needs a scraper, glue scraper. This one was made from a paper shear. It's got a carbide edge here. I didn't do the welding because it's too pretty. I think my brother did that. He's better at it than me. But turned the handle and made that. We did a lot of the urethane patterns. So we'd take either a paper cup, styrofoam cup, whatever we had, and any excess urethane we had left over, we'd pour into the cup and we use it to build a mallet with. Same thing, softer hammer. We did the same thing with that. It's worked well over the years. And those are the last of the things that I really built during my apprenticeship that I needed. But when we get right down to it, there was a couple other things I needed that didn't need to be built. So let's get rid of these. That should be right. Okay, these are some of the things I needed. So let's get them in some kind of order here. Okay, so to start out with, of course, yeah, let's start with that one. We worked with both English and metric tools, or drawings. So everybody needed a metric conversion table. And I found out that was a waste of time, so I eventually got both a metric set of shrink rules and standard shrink rules. So this became obsolete over time. Didn't really need it, but it came in handy when I did. So we had that, and let's just set that up there. Another thing, you need the working data for the casting. So got all your metals here. Some of them we didn't even bother with, but the ones we did, aluminum, brass, iron, steel, malleable iron, those are the ones we used. Got your melting points, your shrink factors, your weights per cubic inch. If you're building a mahogany pattern, it's got a factor, so if you say aluminum casting, you're going to build a mahogany pattern. If you weigh the mahogany pattern, you can calculate the weight of the casting by multiplying it by 5.5. Got your tensile strength, yield point in pounds per square inch, and the elongation, which those we never even used. But this came in handy if you got a pattern that you weren't sure of. Foundry sometimes changed the values that they wanted. Like I said, some of the stuff we built was large cylinders. They were for a plywood press and other things. So we'd use for steel castings, we would use 1/4 inch for the outside, but because they're using an air set sand, it may not shrink as much as they want it to, so we would use 3/16 for the ID of the cylinder, and that worked well for that foundry. So that one was really good. Another one that came in handy at the beginning, just kind of know it after a while, and that is your draft angles. How much per inch? So you got a common one would be a 5° here, and it goes down to 1 inch here. So 5 degrees with a 1 inch, I can't read that anymore, I'm getting old, 0.087. So 5 degrees over 1 inch is going to equate to 0.0, yeah, I think that's 87. That's where I need my magnifying glass. Anyway, this chart came in handy. We did that, so usually on something like a bandsaw we'd cut the thing square. We just needed to know about how much excess we needed on there away from the line we drew to sand off, and that worked really good. And since we did a lot of round stuff, if you needed to calculate your segments, here's your segment chart all the way up to 36 segments, from 3 to 36. Take the diameter times this factor over here, and that'll tell you the chord length of your segment. So real easy to lay out then. And these were the formulas you needed. You could calculate the area. Chord length is this straight line across here. You could calculate the length of the arc for a particular curve. Didn't really use this much, but there was a couple times it came in handy. So those were necessary. And then we come in here, we got the drill and tap chart. That came in handy. And we did some machining, so I did get into a little bit of CNC work too. So your cutting speeds is here now, and with this one we would calculate speeds and feeds based on this chart, and you could, for the amount of horsepower your machine was, your material removal rate, you could calculate your feed rate and your RPMs per minute to surface feet. So all these calculations were easy to use, pretty straightforward, and they worked handy. And after a while you just kind of get to know what you can get away with and not get away with. So that was just stuff we used in the pattern shop. And one last thing, we made a lot of our own turning tools. So every pattern maker needs it, and what worked really well for me for big stuff, like I said, this was all big things, you know. If it was considered small if it was 3 foot in diameter, or it was considered big. The biggest thing I turned was 10 foot in diameter. So we got 3 tools here. So we got this one. These are made from 1/4-inch thick files. I found it a place we used to have around here that was a lot of fun, Boyne Surplus. As you can see, it's been a while since I've used them. But you grind this off as best you can. Get this smooth. Grind your shape in the end down here. So I got a round nose. This is the one I use mostly for roughing. That took off the segments really quick and nice. And this is what we called a toothing iron. On this side I did not grind the edges off here, the teeth off, whatever. I left the roughness on there. And ground this side smooth. And what this was for is it would leave ridges. So when I get down close, we turn to a template. When I get down close to my template, I would use this to fine tune it. It would leave grooves in the material. I would check it with the template, and when I got close I knew I only had about a 1/64 to take off. And we did turn 2 dimensions, so they had to be pretty accurate. And turned the handles on the lathe myself. I do have a set of originally they're old Craftsman, not old, I bought them brand new, but they're Craftsman tools, and they worked for the finer details, anything I had to put in that way, but they are decent turning tools and I never had a problem with them. So let's get a couple more things down and we'll discuss maybe a little bit about what pattern making was like in the 70s. Okay, so this is Patternmaker's manual. This is a 1986 version. I actually started my apprenticeship in 73. Got this, of course I was out of my apprenticeship by 86. So, but everything is the same. Had your employer, which was the owner of the company, the committee, which is the union, the apprentice, and an agreement was signed. And they shall teach me. So what it was when I signed on, I had a 6-month probation period. It wasn't the boss who determined whether or not I was going to be a journeyman or not, or finish my apprenticeship. It was the journeyman in the shop itself. So there was a contract signed between me, the employer, the union, and overseen by the state. So if I didn't impress the journeyman, I wasn't going to make it. And that's just the way it was with union, and I kind of like that because it kept things going on an even keel. After about 4 years, well, let's get back to the beginning. My first job in the pattern shop was I had a pump housing that had been sitting in a warehouse for I have no idea how many years. And my job was to clean it up and get it ready for foundry use again. That particular pattern and core box was probably about pump housing was about 4 feet in diameter, and the core boxes were roughly about 6 inches deep, and it was a mess. It had well, let's say I just spent about 2 weeks cleaning bird droppings off the whole thing. I personally think it was a test to see if I'd make it, because I spent 2 weeks. At that time we didn't wear a dust mask. I just used a putty knife and a scraper, a lot of sandpaper and elbow grease to get all the bird droppings off it, and then putty up any cracks and fix anything that was wrong with it, and then paint it up and make it look pretty again. So I got that done. They must have thought I was good enough, because I made it past the 6 month and never had a complaint, so we went on from there. At about 4 years, the boss came out. We did a lot of shipyard work, and he said I was doing the journeyman quality work on the shipyard stuff we did. We built the deck bolsters and hawse pipes and anything else we needed. We had the shipyards out in Seattle. I told him when he asked me if I wanted to just become a journeyman because I'm doing that quality of work, I guess, at the time, and I told him no. So as soon as I become a journeyman, the guys I'm working with, I'm at their level, and if I got a question on a different type of job, they don't have to tell me because I'm supposed to be a journeyman. So I told him no. I finished out my 5 years. At the end of 5 years, asked a couple of journeymen what they thought I should do next, and they asked me what kind of pattern maker I wanted to be, and I told them I want to know as much of everything I could possibly do to improve myself in this trade. And they says, well, you got one of two choices. I can stay in the shop where I'm at and know everything about the shop, or I could quit and learn as much from every other journeyman in the area. There's a reason you're called a journeyman, is because that's what you do. So I quit, went to work at a different shop, learned a bit more. The boss had no problem with that. His dad and his grandfather were both journeyman pattern makers, and he understood my reasoning and told me that I'd have a job anytime I came back. So that worked, and I was back at that shop several times in the course of my career. But all in all, it's a good trade, but it's going away quickly. The time I started my apprenticeship, there was about 15,000 union members between the U.S. and Canada. Last I heard, which was a few years ago, there was less than 5,000 between the U.S. and Canada. So it's a good trade to get into at that time. Not so much anymore. But this book has a lot of information in it. It talks about different woods, equipment. It's a good book to get if you want to learn about the trade. It goes through a bunch of different things. Split patterns, how to build them, where to build them, molding, how to mold different patterns, and just various things. We used a lot of this stuff in here. We made a lot of this stuff. That's about it for this video. I'll see if I can chop it up into smaller pieces and get something out there. So talk to you later. Bye.